Let's see the part 5 of ionic equilibrium. Part 5 of equilibrium or ionic equilibrium. Ionic. Right. Its weightage is 10% in NEET. Right. Find out the solubility of nickel hydroxide is given. So find out the solubility of nickel hydroxide in 0.1 molarity NaOH. Given that ionic product of nickel hydroxide, ionic product is equal to 2 into 10 raised to minus 15, right? It is asked in NEET 2020. So let's see, when ionic equilibrium, ionic hydroxide dissociate, what it forms. So nickel hydroxide, when it dissociate, it form Ni2 plus 2OH minus, right? So suppose the starting solubility is S, so it will be S into 2S, right? We multiply with this coefficient. Now see, and for the sodium hydroxide NaOH, when it dissociate, it form Na plus OH minus, right? So its concentration is given, that is 0.1. So it will be 0.1 molarity producing 0.1, right? So total OH will be, so see, total concentration of OH minus will be is equal to this OH and this OH, right? So it will be how much? It will be 2S plus 0.1, right? Which is equal to approximately 0.1, because S will be very small, very small. Suppose number is 0.00000001. So it is approximately equal to 0, right? In the similar manner, we have taken S as 0. So it is coming out to be 0.1, right? So ionic product will become, for the nickel hydroxide will be ionic product is equal to Ni2 plus into concentration of OH minus raised to 2. So ionic product value is given, that is 2 into 10 raised to 15. So right here 2 into 10 raised to minus 15 is equal to Ni value is S, right? So put here S, and OH minus value we know now, that is 0.1. So it will be 0.1 raised to 2. Now find the S value. So S will be equal to 2 into 10 raised to minus 15 divided by 0.1 raised to 2. So it will be 0.1 into 0.1. So S will be coming out to be as 2 into 10 raised to minus 13. So write this value. Now see the question number 2. Conjugate base for Bronsted acid H2 and HFR. Bronsted base. Conjugate base, we have to find it out, right? So scientist name is Bronsted acid, right? So of water and HF. So C, for water, when it dissociate, it form H plus OH minus, right? And if it again react with water, oxygen having lone pair, right? So this H plus is attract towards this lone pair, and it will form H3O plus. One lone pair is lost, right? It has given to the H plus. So this H3O plus is called hydronium ion. Hydronium ion, right? So you can see here. So there is charge which is negative, right? So it is called as conjugated base. Conjugate base. Understood? And this having plus charge, right? So it is called conjugated acid. This is your conjugate acid, right? According to Bronsted. So Bronsted, how it defines, which is having lone pair or minus sign, then it is base. If it is there plus sign, then it is called acid, right? Now see for the HF explanation. On the loss of H plus, it becomes F minus, right? So when it dissociate, it form H plus F minus, right? So you can see clearly in HF, H plus is there. So it will be conjugated acid. Conjugate acid. This is F minus, so this is conjugate base, right? So now when we react this water with HF, what it forms? Let's see. So when HF, that is your acid, right, plus water. So here water will act as a base, right? Water can act as both acid and base because it is of amphoteric nature. Amphoteric nature, right? So now see. So when it dissociate, it forms what? So it will form like H plus F minus, and it is in water, right? So water, oxygen having lone pair, so it will be attached to this lone pair. So what it forms now? F minus plus H3O plus, right? Now see, so H plus is going to the F minus. So this is acid in the reactant side, F minus on the product side, it is called as conjugate base. Conjugate base, right? And H3O plus is called conjugate acid. Conjugate acid. So this is the explanation of it. Please write. Now let's see the question number 3rd. So following solutions were prepared by mixing different volume of NaOH and HCl. So there is a solution which is formed by NaOH plus HCl of different concentration of it, right? So let's see the explanation now for the first. So it will be, suppose I am taking D option. So it is given that 75 ml, right, of M by 5 concentration of HCl. It is combining with 25 ml of molarity M by molarity by 5 NaOH, right? So since 25 ml into F by M by F NaOH will neutralize 25 ml, right? So you can see this is your base. Why? Because OH is there and in HCl H is there. So this is your acid. So when acid and base react, it is called neutralization reaction. Neutralization reaction. So when neutralization reaction is there, it forms salt and water. So please remember this general formula. When acid and base react, it forms salt and water. So it will form NaCl plus H2O, right? So you can see that here concentration of HCl and NaOH is same, but volume of this acid is more. So it will neutralize how much volume? Only 25 ml, right? Because they are having same coefficient when it reacting. So write here the statement. Since 25 ml M by 5 NaOH will neutralize 25 ml M by 5 of HCl, right? So this is your first. Next statement will be, so volume reduced from the acid will be 75 minus 25. So it will be 50 ml of M by 5 HCl will remain, right? So this much of acid will be remain there, right? So total volume become how many after adding this acid and NaOH volume? So third, write the statement. So total volume will become, total volume will be 75 plus 25. So it will be 100 ml, right? Now see the fourth point. So 50 ml of acid is remaining to dilute 100 ml. So see here 50 ml of molarity by 5 HCl is diluted to 100 ml. So H plus, this is the ionic product of acid, is equal to HCl. So it will form M by 5 into 50 by 100, right? So 50 ml we have taken and total volume. So it will be how much? So it will be 10 and this point will be gone. Then concentration will become molarity upon 10. So this is the concentration after dilution, right? So how will you find the pH now? So pH formula is given as minus log of H plus, right? So now put the value. So it will be minus of log molarity upon 10. So when take M as a 1, then it will be equal to 1, right? In the second step, you can see how we have calculated 1. So pH is equal to defined as minus log of M upon 10, right? So it is minus log of 10 raised to minus 1. So power will multiply here. So it will become minus 1 into minus 1 log of 10, right? So log of 10 is nothing but it is 1. And this minus 1 into minus 1 is plus 1. So pH is become now plus 1, right? So write the whole explanation now. Now let's see the question number 4. So percentage of pyridine. So it is talking about pyridine as compound pyridine. So its molecular formula is C5H5N. That forms pyridinum ion. So it is forming pyridinum ion. Pyridinum ion. Right. So it will be, formula will be C5H5N plus H. Right. In 0.10 molarity. Aqueous pyridinum solution. Aqueous pyridine solution, right? So Kb for this solution is given. Equilibrium constant for the base is, it is 1.7 into 10 raised to minus 9. So you have to find the percentage of pyridine. It is asked in 2016. So let's see the explanation. So when C5H5N pyridine react with water, it forms C5H5N plus H plus OH minus, right? So the amount of pyridine that forms pyridinum ion is alpha, right? So this is the pyridinium ion form. So it is formed as alpha. So write the name of this ion is pyridinium ion. Right, and this is your pyridine. Pyridine. Right. So alpha is given as Kb upon concentration of pyridine. Pyridine. So now put the value. So we know Kb value, right? That is how much? It is 1.7 10 raised to minus 19. So put here 1.7 into 10 raised to minus 19 divided by concentration of pyridine. So concentration of pyridine is given, that is 0.10. So put here 0.1. Now solve it, you will get 1.30 10 raised to minus 4. So this is the alpha. Alpha means degree of dissociation of pyridinium ion. Right. So percentage of pyridine that forms pyridinium ion is given. So you can find percentage also. So this is your percentage of pyridine. Right. So finding the percentage, we have to multiply with 100. So it will be 1.30 into 10 raised to minus 4 into 100. So it will be equal to 1.3 into 10 raised to minus 2. So it is coming out to be 0.013%. So this is your alpha. Now see the next term, that is fifth one. So fifth sum is, what is the pH of resulting solution when equal volume of 0.1 molarity NaOH and 0.01 molarity HCl are mixed? Right. So NaOH whose concentration is given, that is 0.1 molarity. This is volume V, and it is reacting with 0.01 molarity HCl. Right. Its volume is also equal with that of base. Right. So equal volumes are given. Concentration is only different. So they are mixed together. Right. So NaOH is base, react with HCl. It forms salt and water. So it will form NaCl plus H2O. This is your salt and this is your water. This is base, this is your acid. Right. So you have to find the pH of this solution after reacting. So see the explanation now. So concentration of HCl is given, that is 0.01, and for the base, right, for the base it is 0.1. So I have written here wrongly. So it is 0.1. Concentration of base is given, that is 0.1. You can see there. And for the acid it is given 0.01. So it will be 0.01 molarity. Right. So they are reacting to form NaCl and water. So final concentration will be what? So you can see for the base, it is reacting 0.01. So from this, it will be minus 0.01. So write the remaining part. So it will be 0.09. And NaCl will be formed. So this is the initial condition before reaction, right? So initial concentration of salt and water is 0. Why? Because they are not formed that time. Right here, not formed at that point of time. Right. And for the, so it is neutralized now, right? So this will become 0. So it will be 0.01 minus 0.01. So it is getting 0. And how much of salt is formed? It is 0.01 and water is also 0.01, right? So this is the concentration at equilibrium. So right here, concentration at equilibrium, right? So as equal amount of HCl and NaOH are added, so the volume of resulting solution will become double, right? So Initially volume is, this is V, this is V. So after mixing, it becomes 2V. So volume will become double. Volume will become double, right? So the concentration will become half because they are related. So molarity into volume is constant. So when volume is increases, concentration will decrease, right? They are inversely proportional. So concentration will become half of initial concentration, right? So OH minus concentration will be 0.09 upon 2. So it will be 0.045 molarity. So find the pH of this solution now. So POH formula is given as minus log of OH minus concentration. So it will be how much? Minus 0.045. So you can see on the previous slide, it is 0.05 of OH minus concentration. So this will be equal to 1.35. Right. Now see the relation between pH and POH. So pH and POH is equal to 14. Now put the value of POH, it is 1.35. Right. Then you will get pH. So it will be 14 minus 1.35. So it is coming out to be 12.65. So this will be the pH of the solution after the reaction. So please write from starting. So this is very important question.